Hi. I'm sure that you have heard that COVID can cause ARDS, which attacks your alveoli. But why is that important? Well, I'm sure you know that you breathe in oxygen and breathe out carbon dioxide. But that doesn't happen by magic. It happens through your alveoli. Let's take a look. Let's look at a little background. These are your lungs. Each of the tubular structures are called bronchioles, while at the end of each are alveoli. On top of each alveolus are capillaries. This is a site of gas exchange where deoxygenated blood gains oxygen to become oxygenated. Each time you breathe in, oxygen is delivered to the alveolus. The sac-like structure is your alveolus, and surrounding it is the capillary. Within the capillary, there are red blood cells, where the gas exchange actually occurs. Now, as we zoom in and take a closer look, we're able to see that both the alveolus wall and the capillary wall are composed of cells. This means that they're semi-permeable. Semi-permeable means that certain objects can pass through, while others aren't able to. The red blood cells behind the capillary wall, so the gas exchange can occur. Now let's talk about the actual gas exchange. CO2 can either be dissolved in the blood plasma, or it can be stored in the form of bicarbonate ions in the blood. When those bicarbonate ions react with hydrogen ions, they form carbon dioxide and water. This reaction can also occur within the red blood cell, except there's a secret ingredient this time. It's called carbonic anhydrase. It makes this reaction go much faster than normal because it's an enzyme and a catalyst. The last way that carbon dioxide can be formed is when carbon aminohemoglobin dissociates into hemoglobin and carbon dioxide. Thus, the carbon dioxide from all these reactions travels over the semi-permeable membrane and into the alveolus. As for oxygen, it can either be dissolved in the blood plasma, or it can react with HHB to form oxyhemoglobin and hydrogen ions. Those hydrogen ions are used to fuel that bicarbonate reaction, making this huge process one huge cycle. But why? It's not like the particles know when to move. Well, the answer lies in pressure and solubility. Particles will move from an area of higher pressure to an area of lower pressure, and they move faster when they're more soluble or there's a greater difference in pressures. So, when oxygen moves into the alveolus, inside is a pressure of about 104 mmHg, whereas outside of the capillary is about 40 mmHg. This creates a very high pressure gradient, causing oxygen to move from high to low pressure very rapidly. However, for carbon dioxide, the pressure gradient is very small due to a very low difference in pressures. In the capillary, the pressure is about 45 mmHg, whereas inside of the alveolus, it's about 40 mmHg. This means that carbon dioxide will move from high to low pressure very slowly, or so we think. But what are we missing here? That's it, solubility. According to Henry's law, the solubility of a gas is directly proportional to its partial pressure above the liquid, so CO2 should be more soluble than oxygen. Even as oxygen moves out of the alveolus very quickly, carbon dioxide can move almost exactly the same rate due to its increased solubility. Thank you for watching.